Hey folks, in this episode I'm going to show you how to make this audio visualizer here. We're going to be making this in the shader editor, and we're also going to be using adaptive subdivision with micro-displacement. So without further ado, let's get to it. So open up Blender, we're going to delete the default cube, we'll delete the default light, we'll then go to Edit, Preferences, and then under Add-ons you're going to search for Node and then enable the Node Wrangler here. Once you've enabled that, we're going to click this button, click Save Preferences, and that will ensure the Node Wrangler loads every time you load Blender. I'll then close this window here. To use micro displacement and adaptive subdivision, we're going to have to switch it from EV to cycles. You don't have to use adaptive subdivision, so you can follow along using EV. The only difference is you don't use displacement, instead you'll drive it with bump. I'll then change my device type from CPU to GPU. I'll then enable viewport denoising. And for my render noise threshold, I'm going to set this to 0.025. That should speed up rendering slightly. And I think I'll set my max samples to 256. I'll then navigate to where it says lights. I'll expand these options. I'm going to disable light tree. I'll expand light paths. And I'm going to scroll down and I'll disable reflective and refractive caustics. I'm also going to scroll down to color management. I'll expand these options. And I'm going to change my view transform from AGX to ASIS 2.0. I'll then bump up the gamma to 1.5. I'll scroll up all the way to the top. I'll navigate to my output tab over here. I'm going to change my frame rate from 24 FPS to 30 frames per second. And I'll also enable render region. I'll be using my own beat, which is 180 beats per minute. I'll leave a link to that where you can download it for free in the description. And so if Blender is running at 30 frames per second and my beat is 180 beats per minute, we need to calculate how many frames per beat we get. And so I'm going to use a BPM to FPS calculator. I'll go to this website here, vjam.com. I'll then click support. I'll navigate to where it says AV BPM calculator. And so Blender is set to 30 frames per second. And my beat is 180 BPM. I'll then click solve. And that will give us 10 frames per beat. My beat is 4 beats over 4 bars, which gives us 16 beats, and 16 beats times 10 frames gives us 160 frames, and I want the beat to repeat twice, so 160 times 2 is 320 frames. I'll then close this window here. I'll then go to my timeline and set my end frame to 320. In my timeline, I'm just going to hit home, and that will ensure the entire timeline fits in your view. In my 3D viewport, I'm going to hit Shift A, I'm going to go empty, and I'll choose single arrow. I'll then hit Shift D, and I'll escape it back in its original position. I'll then navigate to the empty data tab over here, and for this empty object, I'm going to set the size to 2 meters. In my outliner, I'm going to select the original empty object, and I'm going to rename it to LF multiply for low frequency multiply. I'll then select the other empty object, and I'm going to rename this to LF add for low frequency add. I'll ensure that the timeline is set to frame 1. I'll then navigate to the Object Data tab over here, and with LFAdd selected, I'm going to add a keyframe on the Z location transform set to 0. I'll then select the low frequency multiply empty object, and I'll also add a keyframe on the Z location transform set to 0. I'll then navigate to the bottom left of my 3D viewport until I see a crosshair. I'll left click and drag up and open up a new window. I'll then change this from the 3D viewport to the shader editor. I'll just make this window a bit smaller for now. I'll then navigate to the top left of my 3D viewport until I see a crosshair. I'll left click and drag across and open up a new window. I'll then change this window from the 3D viewport to the graph editor. I'll then hit N to hide the N panel. Navigate to your outliner and select the LF multiply object. Navigate back to your graph editor. Expand the LF multiply action button, expand the object transform, and select your Z location keyframe. We'll then click channel and select sound to samples. I'll then select my audio track, which is Escape Drum Beats Snippets Clean 180 BPM. Again, I'll leave a link to this in the description. Alternatively, you can use your own audio track. On this side panel, this is where we need to input all the frequency data. Here's an audio frequency range chart I made in Blender. The frequency range I'm going to use for this tutorial will be between 20 Hz and 70 Hz. And so for the lowest frequency, we'll input 20, and the highest frequency, we'll input 70. I'll then click Sound to Samples. As you can see, the low frequency audio data is now baked into this chart, and that will affect the Z location of this empty object. So if I just hit play, you should see that this is rising up and down on the Z axis in time with the bass kicks. I'll just skip back to frame 1. In the 3D viewport, I'm going to select the low frequency add empty object. Ensure that we're on frame 1. I'll then navigate into the graph editor. I'll expand these options, expand the object transform, and select your Z location keyframe. We'll then click channel, and we'll select sound to samples. Navigate and select your audio track. Now Blender should remember the last frequency range you input into these boxes. So the lowest frequency was 20 Hz and the highest frequency was 70 Hz. But this time we're going to enable accumulate. I'll then click sound to samples. As you can see, by enabling the accumulate button, the samples add on and accumulate over time every time a base frequency triggers the graph editor. And in my 3D viewport, if I was to hit play, you can see the effect that that's having on these empty objects here. And that is why I added the suffix add and multiply to the names of these empty objects, and that's so we can differentiate between the two. I'll just skip back to frame 1. I'm going to go into the top left of my 3D viewport until I see a crosshair. I'll then left click and drag left, and we'll collapse that window. Next up, we need to bring in the audio into Blender so we can actually hear it. So I'll hit Shift A, I'll go speaker, I'll then navigate to the speaker data tab over here. I'll then click open, navigate and select your audio file, and then click open sound mono. If you were to hit play, you should be able to hear the audio and see the empties reacting. Excellent. I'll just skip back to frame 1. In my 3D viewport, I'm going to hit Shift A, I'm going to go mesh, and I'll choose plane. I'll then navigate to my outliner, and I'm going to rename the plane to ripple.audio visualizer. I'll then navigate to my shader editor. I'm going to click new, and I'll rename this to ripple.visualizer. In my 3D viewport, I'm going to hit numpad 7, numpad period, and that will align the view to the object. I'll then hit Control Alt numpad 0, and that will align the camera to the 3D viewport. I'll then select my camera. I'll then go to my camera data tab over here, and I'm going to change the focal length to, let's say, 70mm. I'll then go to my output tab over here. I want to flip this into vertical format. So for my resolution, I'm going to type in 1080 by 1920. I'll also go to my object data tab over here. And for the Z location of the camera, I'm going to set this to, let's say, 3.8 meters. Maybe I'll drop it down to 3.5. I'll navigate and select my render tab over here. I'll then go to my shader editor and I'll expand the window. I'll then select the ripple.audio visualizer plane in my shader editor. I'm going to hit N to hide the N panel. We're going to create the main pattern with 2 Voronoi textures. So I'm going to hit Shift A, I'm going to go texture, and we'll choose Voronoi texture, and I'll pop that there. I'm going to change it from 3D to 4D. I'm going to change it from F1 to smooth F1, and with the Voronoi texture selected, I'm going to hit Control T, and that will add a texture coordinate and a mapping node. I'll then change the coordinates from generated to object. I'll select the Voronoi texture. I'll just hit G. I'll just bring this over to here. And with the Voronoi texture selected, I'm going to hit Control Shift D, and that will duplicate the node whilst maintaining the connection to the previous node. And I'll pop that down there. I'll then hit Shift A. I'm going to go input, and I'll choose value, and I'll pop that there. I'll then hit Shift D, and I'll just drag this on the y-axis to around about there. Maybe in the shader editor, I'm going to give us a bit more room. With this value node, I'm going to connect this into the scale of this Voronoi texture, and I'll also connect it into the scale of this Voronoi texture. And on the value node, I'm going to set the scale to 4. And with that value node selected, I'm going to hit F, and that will add a frame, and I'll rename this to scale. I'll then select this value node, and I'm going to plug this into the smoothness of the top Voronoi texture, and I'll also connect it into the smoothness of this Voronoi texture. And with the value node selected, I'm going to hit F to add a frame, and I'm going to rename this to transform. For this top Voronoi texture, I'm going to change the detail to 1. And for the bottom Voronoi texture, I'm going to change the detail to 1 and the roughness to 0. I'll just box select these 2 nodes here. I'm going to hit G, just move them out of the way. I'll then hit Shift A, I'm going to go color, and I'll choose color ramp, and I'll pop that up there. I'll then hit Shift D, Y, and I'll drag this down to here. I'm going to connect the distance socket from the top Voronoi texture into the factor of the color ramp. I'll then change the interpolation type on this color ramp from linear to ease. I'll then select this black flag, and I'm going to change the position to 0.05. I'll then select the white flag, and I'm going to change the position to 0.1. For this bottom color ramp, I'm going to select the white flag, and I'm going to click the plus button twice to add 2 flags. I'll then reselect this first white flag, and I'll click the plus button one more time. For this first black flag, I'm going to set the position to 0.01, and I'm going to ensure that it's 100% black, so the value is set to 0. For this second flag, I'm going to change the colour to black. For this third flag, I'm going to change the colour to white. For this fourth flag, I'm going to change the colour to black. And I'll just ensure that this first flag is also set to 100% white. I'll then change the interpolation type from linear to ease. I'll then connect the distance socket from this Voronoi texture into the factor of the color ramp. I'll just toggle on material preview. I'll then hit Shift A, I'm going to go color, and we'll choose mix color, and I'll pop that there. I'll then connect the color socket from this top color ramp into the mix factor of the mix color node. I'll then connect the color socket from this color ramp into socket B of the mix color node, and for socket A, I'm going to ensure that that is set to 100% white. I'll then connect the result from the mix color node into the base color of the principal BSDF. As you can see, we're starting to get the ripple dot effect now. Excellent. So now I think we should add a bit of color to this. So I hit Shift A, I'm going to go color, and I'll choose color ramp, and I'll pop that in between there. On the color ramp, I'm going to click this plus button 3 times. And for this end flag here, I'm going to set the color to maybe a light blue, something around there. For this next flag, I'm going to set this to black, and I'll drag it over to here. For this flag, I'm going to set this to a magenta color. This flag, I'm going to set to black. And for this flag, I'm going to set to orange. I'll then shimmy these flags around. I'm just going to adjust the orange color, make it a bit brighter, maybe something around there. Next up, I'm going to hit Shift A, I'm going to go color, and I'll choose hue saturation value, and I'll pop that in between the color ramp and the principal BSDF. I'm going to change the hue to 0. I'll then hit Shift E, and I'll pop that in between there. And that will reset the colours back to its original state. And the reason I added the hue saturation values is so we can animate the hue with the audio data. Now is a good time to add the bump. So I'll hit Shift A, I'm going to go displacement, and I'll choose bump, and I'll pop that there. I'll then connect the result from the mix color node into the height of the bump node, and I'll connect the normal socket from the bump node into the normal socket of the principal BSDF. On the bump node, I'm going to set the distance to 0.25. I want the inner rims of this material to be metallic, and so I'm going to take the result from this mix color node and plug it into the metallic socket of the principal BSDF. I also want to use the result from this mix color node as a mask for the roughness, but I don't want any part of the material to be 100% shiny because that will look terrible for the light reflections. And I also want to invert the mask itself, so I'm going to hit Shift A, I'm going to go color, and I'll choose color ramp, and I'll pop that up here. I'll then connect the result from this mix color node into the factor of the color ramp. I'll then plug the color socket from the color ramp into the roughness socket of the principal BSDF. I'll then click this arrow here, and I'll click flip color ramp. I'll then change the interpolation type from linear to constant. I'll just zoom into this color ramp. I'll then drag this black flag, and you can see the effect it's having on the material. So I'm going to set the value to, let's say, 0.9. And because I don't want any part of the material to be 100% shiny, I'm going to change this black value to, let's say, 0.5. Okay, we're making good progress. I'll just box select these nodes here. I'm going to hit G, Y, and just bring these down. I'll select this node here. I'm going to hit G, and I'll bring this across. I guess the next element we need to add will be the emission. So on my principal BSDF, I'm going to expand emission. I'll then connect the distance socket from this bottom Voronoi texture into the strength socket of the emission on the principal BSDF. I'll then hit Shift A, I'm going to go color, and I'll choose color ramp, and I'll pop that in between the Voronoi texture and the emission socket on the principal BSDF. I'll then click this button and flip color ramp. I'll then change the interpolation type from linear to constant. I'll then select the white flag. I'm going to click the color swatch, and I'm going to change the value to 10. And this will be the strength of the emission. I'll then select the black flag, and I'm going to change the position to, let's say, 0.25. And now, as you can see, we're getting these emissive spots. You can adjust the black flag to control how much emission you want in your material. For me, I think less is more, so I'm going to keep mine set to 0.25. So we need to colorize the emission now, and that's easy enough. We're just going to take the color socket from this color ramp with all your colors on and plug it directly into the color socket of the emission on your principal BSDF. You won't see much color appear at the moment, but when we add a glare node in compositing, that color will shine through a lot better. I'll just give us a bit more room in the shader editor before we move on to integrating the audio data into this node tree. It's a good idea to save your project, so I'm going to go to File, Save As, and I'm going to save my project as like and subscribe. Thanks folks, you absolute legends, and then click Save As. I'll then navigate this end of the shader editor. I'm going to take this texture coordinate node, I'm going to hit Shift D to duplicate, and I'll just pop this over here. I'll then hit Shift A, I'll go Utilities, we'll go Vector, and we'll choose Separate XYZ, and I'll pop that there. We'll then select this texture coordinate, we'll click inside this object box here, and we'll select LF add for low frequency add. I'll then connect the object socket from the texture coordinate into the vector of the Separate XYZ. And if you remember, we baked all the audio data on the Z location, so we can use this Z socket on the Separate XYZ to drive the parameters in the material. The first parameter I want to drive will be this hue factor here. So I'm going to take the Z socket from the separate XYZ and plug it directly into the hue socket of the hue saturation value node. On this noodle, I'm going to hold down shift, right click and drag, and that will create a reroute node. I'll then hit G, just bring it up to here. I'll then hold down shift, right click and drag, and add another reroute node. I'll then hit G, and I'll just bring this over to here. Maybe I can just drag this color ramp over to here, and I'll drag these two nodes across. And now I can take this reroute node, I'll hit G, and I'll bring it over to here. It just makes it a bit more easy to read. And now, if I hit play, you should see that the hue changes with the beat. Excellent. The next two parameters I want to change with the low frequency add function will be the W factors on these Voronoi textures. To do that, I'm going to hit Shift A, I'm going to go Utilities, we'll go Math, and we'll choose Maths, and I'll pop that here. I'll then change this from Add to Multiply. I'll then connect the Z socket from the separate XYZ into the top socket of the Multiply node, and I'm going to change the value to 1. I'll then connect the value socket from the multiply node into the W factor of this Voronoi texture, and I'll also connect it to the W factor on this Voronoi texture. And now, if I hit play, you should see that the color changes with the beat, as well as the pattern. Excellent. I'm just going to shimmy some of these nodes about to give us a bit more room. I'll hold down shift, I'm going to right click and drag through these two noodles coming out of the multiply node. I'll then hit G, just bring these across over to here. Currently, with this setup, the W factor will only change with the low frequency audio, but I want the W factor to change regardless whether a low frequency hits or not. And to do that, I'm going to add a driver. So I'm going to hit Shift A, I'll go Input, and I'll choose Value, and I'll pop that up here. And in this value socket, I'm going to type in hash frame divide by -250. I'll then hold down Control, right click and drag through this noodle, and that will disconnect the audio from triggering the W factor. I'll then connect this value socket into the loop, and if I hit play, you can see that the W factors are now automated. But now I want to mix this in with the low frequency add function. So I'm going to take this multiply node, I'm going to connect the value socket from this multiply node into the loop here. I'll then hit Shift A, I'll go Utilities, I'll go Math, and I'll choose Maths, and I'll pop that in between there. I'm going to keep it set to add, and I'll connect this value node into the bottom socket of this add node. And now, if I were to hit play, we'd get the benefit of this driver automating the warping of the W factor, as well as having the low frequency add function also triggering the W factor. So I just click play, and it gives it a more of a natural feel. Excellent. I'll just skip back to frame 1. Next up, I want to be able to control the strobing of the emission on this material. And if you remember, this color ramp is plugged into the emission strength, and we're going to mix that with the audio low frequency multiply function. So I'm just going to take this texture coordinate over here. I'm going to hit Shift D to duplicate, and I'll just pop this down here for now. We're going to change it from low frequency add to low frequency multiply. I'll then hit Shift A, I'm going to go Utilities, we'll go Vector, and we'll choose Separate XYZ. And I'll pop that there, and I'll connect the object socket from the texture coordinate into the vector of the separate XYZ. Again, we're still going to be using this Z component here because the audio data was stored on the Z location transform. Just zoom out. I'll just take this color ramp and I'll bring this down here. I'll then hit Shift A, I'll go Utilities, Math, and we'll choose Maths, and I'll pop that in between there. I'll then connect the Z socket from the separate XYZ into the bottom socket of the Math node. I'll then change the Math node from Add to Multiply. On this color ramp, just for now, I'm going to select this white flag. I'll select the color swatch, and I'm going to change the value back down to 1. We'll then take this multiply node. I'm going to hit Shift D to duplicate, and I'll pop it in between there. So the value on this multiply node is going to be the strength of the emission. So I'm going to set this to 125. We're not going to see any emission appear on our material, and that's because the values from the low frequency multiply object isn't going from 0 to 1. So we need to remap these values. So I'll hit Shift A, I'm going to go Utilities, Math, and we'll choose Map Range, and I'll pop that in between the separate XYZ in this multiply node. From min is going to be -1, from max is going to be 1, to min is going to be 1, and to max is going to be -1. And these values here won't just trigger the emission to go on and off, they should trigger on and they should fade out over time. Maybe I'll just select this multiply node, I'm going to hit G, and I'll bring this over to here. I'll just shimmy these around. I'm just going to hit play. Excellent. And as I mentioned before, on this multiply node, you can increase or decrease the value to adjust your emission strength. So with this multiply node selected, I'm going to hit F to add a frame, and I'm going to rename it to emission brightness. I'll just box select these nodes. I'm going to hit G. Box select these two. I'm going to hit G. I'll then select this map range node. I'm going to hit F to add a frame. And I'm going to rename this to strobe fall off. And maybe I'll select this value node here. I'm going to hit F to add a frame. And I'm going to rename this to hash frame divide by -20. And that's just so you know what to put in there. And with this frame selected, I'm going to hit N to open up the N panel. Ensure that you've got your node tab selected. I'll then click color. I'll expand these options and I'm going to give this a custom color. Maybe something around, I'll be happy with that. I'll then take my cursor over that color swatch. I'm going to hit Control C to copy that color. I'll then select this frame. I'm going to enable color. I'll then hover my cursor over the color and hit Control V to paste. I'll then do the same for all of these frames. And that's just so we can easily identify the controllers. So on this frame where it says scale, obviously that's the scale of the effect. Now if you change the scale to something small, you may have to reduce the speed on your driver, and to reduce the speed you increase this number. So if I wanted to half the speed, I'd replace 250 with 500 for example. Also, as a bonus, I've added this transform function here. And what this does, it transforms it from spots to a pattern. So instead of having ripple spots, we just change this to 1 and it will have blobs instead. And it should work absolutely fine. I'll just change this back to 0. Before we continue with micro displacement using adaptive subdivision, I'm going to set up the lighting in the scene. So I'm going to hit Shift A, I'm going to go light, and I'll choose point light. I'll then hit numpad 1 to go into front view. I'll hit G, Z, I'm going to hold down control, and I'm going to bring it up to round about there. So that's 50 centimeters high. I'll check that by going to my object data tab over here. And yes, it's 0.5 meters, which is 50 centimeters. I'll then hit numpad 0 to go into camera view. I'm going to hit G, Y, I'm going to hold down control to snap it to the grid, and I'm going to snap it on the y-axis 1 meter. I'll then toggle on rendered preview. I'll navigate to my world tab over here, and I'm going to set the strength to 0. And with my point light selected, I'm going to go to my light data tab over here, and I'm going to change the color to a light blue, maybe something around there. I'll then increase the power to 25 watts, and I'll also increase the radius to 0.25 meters. I'll then hit Shift D to duplicate. I'm going to hit Y, hold down control, and I'm going to drag it on the y-axis 2 meters, so we're just below the plane here. And on my light data tab over here, I'm going to change the color to orange. I'll then hit Shift D to duplicate. I'm going to hit Y, hold down control to snap it to the grid, and I'm going to bring it to the center. I'll then change the color from orange to white. I'm going to decrease the power to, let's say, 20 watts, and maybe I can increase the radius to 0.5 meters. I'll just toggle on solid view. I'm going to select my plane object. I'm going to tab into edit mode. I'm going to right click and choose subdivide. I'll then navigate to the bottom left and expand the subdivide options down here. And I'm going to change the cuts to 12. I'll then tab out of edit mode. I'll then navigate to the modifier tab over here. We'll then click add modifier. We go to generate and we'll choose subdivision surface. I'll enable adaptive subdivision, and this is what will give us our micro displacement. I'll increase my shader editor window. I'm going to zoom in. I'll then hit Shift A, I'm going to go displacement, and we'll choose displacement, and I'll pop that there. I'll then connect the result from this mixed color node into the height socket of the displacement node. I'll then connect the displacement node into the displacement socket of the material output. On the displacement node, I'm going to set the scale to 0.1. And now if I was to toggle into rendered view, we're not going to see any displacement happen whatsoever. This is going to be a completely flat surface, and that's because we need to tell the shader editor to treat this as displacement and not bump. And to do that, we'll click the material data tab over here. We're going to scroll down until it says settings, expand these options, and under surface where it says displacement, we're going to change it from bump only to displacement only. And now we're getting physical displacement. I'll then hit numpad 0 to go into camera view. I'm just going to toggle on solid view. I'm going to zoom into my screen and then re-enable rendered view, and that will increase the resolution. I can now zoom out, and this is what we've got. Excellent. We can increase the scale on the displacement, but by increasing the scale, it's going to add more detail in the craters. So I'll just give you an example. If I increase this to 0.25, for example, you can see that we're getting a lot more detail inside, but I want to keep this detail minimal. So I'm going to set the scale to 0.1. So we've got one last step to do before this is complete. I'm just going to toggle on solid view. I'm going to go to my compositing tab over here. I'm going to click new. In the end panel, I'm going to go to view. Make sure that you've got backdrop enabled, and I'll click fit. I'll then navigate back to my layout view. I'm going to toggle on rendered view. I'm going to select a random frame. Maybe I'll go with that one. I'll then go back to solid view. I'll hit F12 and render out a test frame. I'll now close this window. I'll go to my Compositing tab over here. I'll just reduce my timeline, give us a bit more room. I'll hit Shift A, I'm going to go Filter, and I'll select Glare, and I'll pop that in between there. I'm going to change it from Streaks to Bloom. I'll then reduce the size to, let's say, 0.25, and maybe I can decrease the strength to 0.5. Maybe reduce it a bit more, 0.25. Okay, I'd be happy with that. I'll then go back to my layout view. I can toggle on rendered view. I'll then click this drop down arrow here, and I'll enable Compositor for the camera view. I'll just navigate to my render tab over here. Now, although my max samples are set to 256, you could probably get away with using 128 samples, and that will reduce your render times, but I'm going to keep mine at 256. I'll then navigate to my output tab over here. We'll then click this folder icon here, select the location where you want to save your image sequence, and then click accept. Select the file format, PNG, set to RGB with a color depth of 16-bit, should be absolutely fine. But I'm going to go with a file format of OpenEXR with a codec of DWAA lossy, and that will decrease my file size whilst increasing dynamic range for post-production. I'll then toggle on Material Preview. I'll click this drop down arrow. I'm going to select Scene Lights and Scene World. I'll then hit Ctrl S to save my project. I can then toggle on Solid View, and then it's simply a case of hitting Ctrl F12, and that will render out your image sequence. When the animation has finished rendering, just open up your image sequence in a video editor of your choice alongside the audio file. Just ensure that your video editor is set to 30 frames per second, and then render that out as an MPEG-4, and you should be good to go. Join me on Patreon as a free member, and you'll have access to this file alongside other Blender files from previous tutorials. That's the tutorial in a nutshell. I hope you found this useful. If you did, please click like and subscribe. It really helps my channel. Have a great day, level up, and thanks for watching.